reiterate some of the key concepts that you learned during this course, which sometimes you find it useful, and also sometimes some people find it difficult or confusing to start with, particularly classifiers. So let me give a sort of one more round of uh, repetition of the same concepts, which is of course available in the lecture. So how do you build a classifier, and how do you assess the performance of the classifier or test the classifier um, is the key topic in classification. And once a classifier is built, then it's about assigning each new object to a given class. So, based on the rules that are formed during the classifier building or induction. So, in order to measure the performance of a classifier, you have multiple measures. Okay? That is one thing to keep in mind, because a classifier is not as simple as a regular dependent model, like where your dependent variable is a continuous value variable. Then you, for example, if you build a regression, then for prediction, okay, then you can have a measure like the mean square error, which is a single measure, and you don't need anything else to assess the performance of the model. But in the case of a classifier, since you have multiple classes, and each of these classes are formed based on the training data, and because the training data can contain these different classes of data in different proportions, that itself can lead to certain uh, differential performance of the classifier with respect to different classes, okay, or classification into different classes. So that's known as a class imbalance problem. But before that, uh, we learned that there are generally 5 measures that are used to measure classifier performance. One is the overall accuracy, given by true positive plus true negative, um, divided by total number of records. Okay, uh, that is in the first row. The other is the error rate, which is also 1 minus accuracy. Okay, so that is false positives divided by false negatives divided by uh, total number of records. And then there is something, a measure known as sensitivity or true positive rate, also known as recall. Okay, so that's how it becomes a bit confusing, because you have so many terms to denote the same concept. Okay? But you don't have a choice. This may be used interchangeably in various books. So true positive rate is TP divided by P. And then there is true negative rate, which is specificity, which is given by true negative divided by number of N, okay, number of records in the data, which is N, okay, actually negative. And precision, which is the last measure, is an interesting measure, which is given by true positive on the top, of course, but the denominator is true positive plus false positives, or of all the positives that is detected by the classifier as positive, how many are actually true positive, okay? And that is known as precision. Okay, and each of them have applications, or it gives different insights to a decision maker while one uses these classifiers for actual use. So, so this exercise you have seen already, and I told you about class imbalance problem, which is an issue with the training data, okay? Or the data that you actually use to train and subsequently test the model. Okay? And here in this example, in the given table, you can see that the number of A's or positive records are only 300, whereas the number of negative records are 9,700. So the tree or the model is able to learn about positive classification only from 300 instances, okay, or 300 records. Whereas to learn negative class, it has 9,700 records. Okay, so therefore the model learns relatively very low about positive classification as compared to negative classification. Cases like fraud detection, which we talked about, where the number of frauds would be very low as compared to the genuine cases, and hence we have a problem there. And correspondingly, you can see the recognition rate or the positive accuracy or the sensitivity is very low, only 30%, whereas the specificity is very high, okay, which is 98.56. Okay? Or in other words, this will not function well for detecting true positives, or when true positives, say, we know that P is equal to true positive plus false negative. Okay. So what happens is when true positive detection is low, what happens? A lot of true positives get detected as false negatives, okay? Or they are not recognized by the classifier. Therefore, in this case, since true positive rate is very low, what happens is false negatives will be very large, okay? Or a lot of genuine true cases will be detected by the classifier as false negatives. Okay, that is the implication. Whereas here you can see um, n, which is about n is equal to true negative plus false. Okay, so this particular classifier, since true negative rate is quite high, 98.56, so it will have very less false positives. Okay? False positives will be very low, but false negatives will be very high. Okay, and if false negative is not something that you don't like, okay, or it is the cost of misclassification is high for false negative, then you cannot use this tree. Okay? If it is deployed for um, fraud detection, for example, a lot of cases will not be detected. Okay, they will be false negative. They are actually positive, but a lot of frauds will not be detected by the classifier. That's the implication of class imbalance in training set. So in order to overcome that, we discussed that you can actually resample your training data such that there is the negatives and the positives are balanced in the data set that we use to build the tree or build a classifier. I hope this concept is clear to you, so that when you look at models, you are able to interpret the sensitivity, specificity, um, precision, etc. In context. Okay, and because context means where you deploy the model matters very much. All right, so we don't want to talk about this because it's already there in the lecture, and then you have seen ROC, receiver operating characteristics, and area under the curve, which is point estimate for the model performance. And you can compare different models based on based on the area under the curve of the ROC curve. And an ideal curve should actually shift towards the left. We have seen that where the true positive are captured with minimum false positive rate. Okay? So that is the idea in charting them, so that visually you can understand how different models are performed. And you can also use ROC curves along with precision recall curves to get more insight about the same model. And we already saw that the PR curve should shift towards the uh, northeast, okay, the northeast, whereas the ROC curve should move towards the northwest. Okay, so that's the idea. Okay. Otherwise, it shows a lot of cases have been detected which are actually false positives, in the case of PR curves. Okay. So all these you may have to iterate again so that you develop clear understanding about what their implications are when you deploy them. And this instance of information retrieval, which is an application of data mining for search, when you search documents, for example, You may get a lot of false positives, you may get a lot of false negatives. So therefore, it has implications for recall and precision. Okay? And effort, basically, there is cost for every error. Okay? So the effort required to um, filter out the true positives from a vast ocean of um, false positives becomes very high when the precision is low. So basically, um, this particular uh, example um, is useful in understanding the importance of precision as a measure. Okay. Okay, so that ends your lessons. Okay, I just reiterated the key lessons in classification, and you can ask more questions uh, from the chat box. Maybe I will stop sharing this unless there is any question. I got a good morning from one of the participants. Thank you. Good morning. And if you have any questions, you can post in the chat box and I'll be happy to answer. And I think there was some question related to calculating the CLV in the last week. So maybe we will explain that to you. Forum. Sorry, I think I was mute. Hello, could you hear my explanation? Okay.
No, sir.
Hello, could you hear my explanation of the CLB?
No, sir. No.
I was on mute. Okay. All right, this is the formula. Customer lifetime value is given by 0 to T. T meaning the time horizon. You want to consider for 5 years or 3 years. If year uh, is your period. If you want to calculate in months, then it could be the number of months. So it is PT minus CT means the price minus cost, okay, which is a measure of profit for in each time horizon, each time period into survival rate because the number of customers who joined either in a cohort or in a at a point in time actually keeps declining based on survival rate. So into survival rate divided by the discount rate, which is actually put over uh, the time horizon or to the power 1 plus I is the discount rate to the power of t being the time, minus the total acquisition cost. Okay. So this is dynamic with respect to time, the first part of the formula, and this is one time, okay, which is calculated, which is subtracted in the first time period itself, and then it doesn't have to be deducted. So that gives the overall value. Okay, so ultimately what you calculate is a value or a contribution of the customer uh, projected to the future. Okay, you want to know based on the historical data within the customer how far or how much the customer will contribute in future to the business. That's what it is trying to measure. Hello, I hope this is clear. And if you have any questions, you can put this onto the chat box. Any other questions? So if there are no more questions, we will close here and do continue to learn and ask us questions through the regular chat or email forum. We will be happy to answer your questions and do work on the assignments and do make use of the reading materials which are referred in the course outline. That will help you prepare for your uh, examinations. Uh, in addition to the lecture materials, in the course outline, there are more materials which are available online and which are referred there. So please read them as well. Okay, thank you very much. We will close here. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.